So just like Olivia asked, are these the only geometries that we need? No. So there are other molecular geometries that are out there that we come up with names for when we start cleaving off these bonds and replacing them with lone pairs. What we're going to do now is we're going to look at each of these electron pair geometries and see what molecular geometries are hidden in them. While we do that, we're also going to draw a handful of Lewis structures. So we're going to get some more Lewis structure practice in there, okay? Any questions so far? Oh, we forgot to put the bond angle here. What's a bond angle between any two adjacent atoms in this case? What did we say?
90.
Yep, 90 degrees. Okay. So back to the molecular shape stuff I was rambling on about. So molecular shapes. And this is the shape of the molecule considering only the bonds. Bonds. And the electron pair shape. Okay, the thought process for trying to determine molecular shape is as follows. You basically need to figure out the number of effective pairs. Then you determine the electron pair shape. Then you see how many lone pairs are on the system. And that will tell you the molecular shape. Okay, so let's start with the simplest case that we have where we have two effective pairs around the central atom, and then we'll figure out what that molecular shape is. Okay? I'm gonna just wiggle this up. We got two effective pairs. And we're going to shorten electron pair shape to EPS. If we have two effective pairs, what is the electron pair shape?
Linear?
Yep, it's linear. All right. So, if we have two bonding pairs, whenever you have the same number of bonding pairs as effective pairs, the molecular shape is the exact same as the electron pair shape. So, let's look at some examples and then we'll try and show what is that molecular shape. Let's consider one of our examples, beryllium dichloride. Okay, how many valence electrons does beryllium have? Anybody know?
2.
Yep, 2. Plus 2 times, how many does chlorine have each?
7.
Yep. Total of how many valence electrons then?
16.
Yep. Okay, what's the central atom in this case?
Beryllium?
Mm-hmm. Draw some bonds. Okay. Where should I start plunking valence electrons around?
Around chlorine.
Okay, why chlorine as opposed to beryllium? Does anybody have a justification?
The octet rule?
Well, remember, chlorine's in that third row, so it doesn't necessarily have to follow the octet rule. So you have a choice to either put it on chlorine or beryllium. What are you gonna pick and why?
Chlorine's more electronegative, so the electron should go around chlorine first.
Exactly. So the chlorine's more electronegative. It's going to want that electron density or sap that electron density more. The other thing is if we start clunking valence electrons on the beryllium and we calculate formal charges, we're going to get really wonky formal charges. So let's start putting it around the chlorines. If we do that, I think we've run out of valence electrons. Do we need any formal charges in this Lewis structure? Nope, we're good. Okay, now looking at this beryllium, how many effective pairs are around that center atom?
2.
2. How many bonding regions are around this atom?
2.
Because remember, effective pairs are a little bit different. Effective pairs also consider lone pairs around the central atom. So how many regions of bonding do we have?
2.
We have 2. So we have 2 bonding pairs. And I said whenever you have the same number of bonding pairs as you do effective pairs, the molecular shape is the same. So what is the molecular shape of this system then?
Linear?
Yep. And now knowing that, you could probably tell me the approximate bond angle along here. What's approximately the bond angle going to be?
180.
Yep. Okay. Linear is kind of boring because we're only going to consider 2 bonding pairs in this case. Let's move to 3 effective pairs and then we'll start cleaving some of the bonds off. Okay. Am I all right to move this? Okay. So 3 effective pairs. Oh, we're almost done. Sorry, my alarm didn't go off. Let's do this one and then we'll call it a day and we'll move to the next section next time. Sound good? Okay, so if we have 3 effective pairs, what does the electron pair shape have to be?
Trigonal planar.
Yep. Okay, let's draw one of these molecules out. So we're going to start with 3 bonding pairs. So let's look at boron trifluoride. If we draw that guy out, that's what we get. Okay, you can probably tell me what is this bond angle along here? Or can you tell me what is the molecular shape in this case?
Isn't the angle 120?
Yep, it's 120 degrees. And what's the molecular shape of this system going to be?
Trigonal planar.
Yep, trigonal planar. Okay, last one and then we'll be done for the day. Let's look at 2 bonding pairs and 1 lone pair. So we've seen a molecule with this a couple of times. When we were talking about resonance, we had O3. So if I go to draw that guy out, There we go. But what am I missing in this Lewis structure?
Formal charge.
Formal charge on this oxygen, what's it going to be?
0.
Center one.
+1.
Yep, +1. Last one?
-1.
Yep. Okay. Anybody have an idea of what this molecular shape's name is going to be?
Bent.
Yep, it's bent. So see, in this case, because we lopped off a bonding region, we ended up with a new molecular shape. Does anybody know the approximate bond angle along here between these two oxygens? Doesn't have to be dead on, but close. It's going to be around 120 degrees. Okay. So next time we're going to go through the other effective pairs, the other electron pair shapes, and we're going to talk about the molecular shapes we can make within them, and we're going to practice some more Lewis structures. Okay? I highly suggest for you to check this chapter out in your book, get familiar with these, start drawing Lewis structures and trying to identify their electron pair shapes and their molecular shapes. Okay? Are there any questions about anything we talked about? Oh, I see somebody in the chat, sorry. Oh, never mind. Yes, a video of the lecture will be posted up on YouTube, so if everybody is okay with that, I think your faces will all be out of it, so they'll be up on YouTube to check out. Okay? Any other questions? All right. You guys have an awesome day. If you need to see me for office hours, just send me an email and I'll send a link out. If you want to meet at different times in the day, just let me know ahead of time and I'll see what I can do. Okay? All right. I miss hanging out with you guys. I hope everybody's doing okay at home. Don't forget about your course evaluations. Get them done as soon as possible. Okay? All right. No questions? All right. I'll see you guys later.
Thank you.
Yep. Have a good one. Yeah, Olivia, we can wait. We can talk
Okay.
right now. Well, we'll wait a minute.
That's fine. Who's calling me?
Anshu, I hope you feel better. I'm going to boot you out, though. I'll see you later. Okay.